We are now going to decompose repeated linear factors. So remember, a repeated linear factor is whenever we have a power on the factor. And so we're just going to solve the one problem, or decompose the one problem, x plus 5 over x times x minus 1 squared. So since this is what we're starting with, we know that there's got to be an x. So there's going to be an a over an x. And it looks like we're going to have a b over an x minus 1 squared. But here's the problem. Notice this square? It turns out that there might be a case where we have just an x minus 1. So the idea is when we're getting ready to break this down, all we want to do is look at the highest power and start with it and then decrease by 1 until we get to the end. So for instance, and we'll come back to this problem, but if I had something over x minus 3 cubed, I would break this down as an x minus 3 cubed plus an x minus 3 squared plus an x minus 3. So just start with whatever that power is, and then decrease by 1, and then just put a single variable on top, a, b, c. So a cubed is going to produce 3 pieces. To the 4th power, it will produce 4 pieces. A 7th power would produce 7 pieces. So come back up here. And again, we're going to take this equation, we're going to multiply everything by the x times x minus 1 squared, which is going to divide out and leave us with an x plus 5 equals a times x minus 1 squared plus b times x plus c times x minus 1. And again, these should all be blue so that they stand out just a little bit better. These are the new pieces. This is what it's missing. So x minus 1 squared is x squared minus 2x plus 1. X is easy, and this becomes x squared minus x. So here we go. We take our pieces in, and we distribute them. So we're going to get x plus 5 equals ax squared minus a 2ax, let's put the number first, plus a plus bx plus cx squared minus cx. All right. Well, notice that we have x squareds over here, but we don't have any over here. So if we don't have any, then we need to put a 0 in front of it and a 1 in front of the x. And so we're ready to group our pieces together. For our x squareds, we're going to get an ax squared plus a cx squared, and that's going to be equal to 0. For our x's, we're going to get a minus 2a plus b minus c, and that's going to equal 1. And then for our last one, and these tend to show up a lot, and they're really important, we're going to get for our constants just a single a equals a 5. In fact, that's where I'd start. Notice that in solving this system, we already know what a is. We know that a is 5. Well, if we know that a is 5, then we know that 5 plus c is 0. That's equation 1. A plus c is 0. So that implies that c is minus 5. So now I know a, and I know c. Come back to x, and we get minus 2 times 5 plus b minus a minus 5 is equal to 1, so that's minus 10 plus b plus 5 equals 1, or b minus 5 equals 1, so b is 6. So now I found my a, I found my b, and I found my c, so I just need to come back up and rewrite this, and notice I need to be very careful about how I'm rewriting this. So I'm going to get 5 over x plus 6 over x minus 1 squared minus 5 over x minus 1. And here is my partial fraction decomposition of x plus 5 over x times x minus 1 squared. So again, the really important key here is to start with whatever that repeated factor is and decrease by 1 until you get to the end. And then make sure you put your right variables back. So the b is over the x minus 1 squared, so when I find the b, it's got to be over the x minus 1 squared. And if you do that, then you can decompose these repeated linear factors.